Hello, my name is Akiyoshi from Lancers. The robots have been in the spotlight in the industries and services, and also in the military applications as well. For example, I happen to have a Roomba. This is cleaning robot in the office, and also the drones are getting lots of attentions and attractions. So robots are now moving into this new era and receiving lots of attention. And Google and Apple, those the global companies actually started their heavy investment in robotics. How about here in Japan? Since 1980s, of course, industrial robots have been well deployed, particularly in the automotive industry. So, robots, what's going to happen to the robots, and as time goes on, what kind of impacts are we going to be having due to these robots? And that said, we have honor to have two invited speakers. One is Charlie-san, another is from ispace. We have Hakamada-san. Would you please come onto the stage, please? Let's welcome them with a big round of applause. Please help me. Well, thank you. Let's wait for the Charlie being settled down. But simultaneous translation between Japanese and English is going to be available. And first, Charlie-san, you have 30-plus years experiences in robots business, and now you are serving as CEO at Grabit. Charlie, could you briefly introduce yourself to the audience, please?
Konnichiwa. Hello, everyone. I'm Charlie Duncheon. We'll do it again. Konnichiwa. Hello, everyone. I'm Charlie Duncheon, co-founder of Grabit. Grabit is a Silicon Valley-based robot startup company. We started in 2011, and we specialize in robots using electroadhesion grippers, which I'm going to talk about here for the next 4 or 5 minutes. When you buy robots today, you don't buy them with hands. The robots have done a great job, the designers, in emulating the human waist, emulating the human shoulder, the human elbow, the human wrist, but not the human hand. The challenge to grow robots in this world of very high mix production is to have grippers that can handle a broad range of products. And we at Grabit are trying to do that, not by trying to emulate the human hand, that's too hard, just a flexible gripper that does the same thing that the human hand can do. Because traditionally, robot automation for material handling, the grippers have been part specific. So we're going to talk about some technologies, including ours at Grabit, that are making robot grippers more flexible. If you look at technologies that enable higher robot growth, the first one that showed up in the 1980s was all of a sudden robots with vision, robots with eyes. That accelerated robot growth. Recently, we've had the introduction of collaborative robots that is now accelerating robot growth, robots that can work side by side with people. I would submit that flexible grippers are now going to grow robots even faster by virtue of enabling new applications that robots could not do before. And then after grippers, maybe artificial intelligence that can certainly accelerate robots even more. So here's a video of adaptive fingers by a company called Robotique doing complex assembly. This is something that could not have been done a few years ago. Another technology called jamming technology. It's really, I call it a bean bag approach. It's granules in a bag that surround a part. You pull a vacuum, draw the air out, and the bag collapses around the part. As you can see from this video, it can handle a broad range of parts. This is done by a company called Empire Robotics in New York. And then at Grabit, we use electroadhesion. And we started with two-dimensional parts. We apply voltage to the gripper. That gripper then applies charges to the surface of the part we want to handle. Opposite charges attract, and we pick up the part. So with old technology, one gripper could handle this packet, but a totally different gripper would handle this cell phone. I have a sample robot gripper here from Grabit. Voltage, so we turn voltage on, we pick up the cell phone. The electroadhesion does not damage the operation of the cell phone. But that same gripper can pick up the package. Electroadhesion. Also the same gripper can pick up a pocket for Levi or a blue jean sewing operation. This is something that to date has always been done manually throughout the world. We can now automate loading and unloading of automated sewing machines.
Charlie, easy to use. Can I try?
You want to try? Yes. I haven't trained you. Just hold it down.
簡単ですね。
Very easy.
So at Grabit, we started in the two-dimensional world, fabric, printed circuit board, sheet metal, glass. And these are videos showing, on the lower left, you'll see pockets being destacked from a stack one at a time. And as I said earlier, could load the jeans that they're sewed on or the shirt that they're sewed on. We add vision so that the robot can know the orientation, in this case a flexible circuit. We put lighting behind the gripper, the LED lights, so that then we can see the orientation of the part we're handling. And the camera looks up and tells the robot the orientation. We also can handle broad ranges of boxes with this two parallel gripper, all these different size boxes handled with one gripper. And a huge potential application, literally a multi-billion-dollar robot opportunity, is in e-commerce order fulfillment, the handling of individual items ordered on the internet. It's all done manually today, very mundane. We're showing here one Grabit gripper handling a very broad range of parts, using vision to see the parts. That same gripper can handle tomatoes, apples, peppers, and handling it gently but firmly so that it does not bruise vegetables or produce. So I'm an industrial person. I've spent many years on factory floors, and I believe that if we can perfect these grippers that handle broad ranges of parts in warehouses and factory floors, that will then enable the ability of robots to enter the homes for healthcare, for personal servants, and other activities in the home. And lastly, you can't do a Silicon Valley presentation without a drone. So this is a drone that we bought at Grabit. We put our fingers on the drone, and you can see them. We did this in our parking lot. You can see the voltage is on, the fingers wrapped to the box. We pick up the box, fly it across the parking lot. The first time we crashed into the building. We go above the shipping container, turn the voltage off, and then wave goodbye. That's Grabit, and these are the other companies who I mentioned. And again, I'm quite honored to be here with you this afternoon and look forward to the rest of the session.
ありがとうございます。すごい簡単で。
Thank you. It was easy for me to follow it, and also it was fun. Well, let me introduce the Hakamada-san. Actually, your mission is to build best environment in space and for humanity. Thank you for introduction. My name is Hakamada, and my company is called ispace. Actually, I'm involved in the lunar surface and activities, and this is part of my grandiose the ideas to make my contributions so that the people can start living in space. Actually, since I was a little kid in elementary school, and also I was interested in the robots, and also Star Wars really impressed me, and that became quite motivational as far as I'm go. Well, the space. What is space? So allow me to begin with this slide. What is actually going on in terms of space development, and using this slide? Well, the new space, I think, is gaining lots of traction in the U.S. and in other geos. Actually, the major player in space, the for space, has been the central governments. However, now there has been a shift from the central governments to the private sector, and those entrepreneurs are making the great contributions, low cost access to space by entrepreneurs. I think this started. I think there are three important points behind. One is U.S. and other countries actually. Now there is a shift. The market's been opened up. They used to be conquered by the central governments, but now opportunities are given to the private sector. And then the second is low-cost production. In manufacturing rockets, actually, cost has been reduced by 1 digit, by 2 digits. And the third point, the external people, those entrepreneurs, are participating in space. So diversity is taking place. So this diversity, I think, is going to help us to get to see a more active innovation in the space. So the new space story, and Google Lunar X Prize is now going on. I think through this X Prize, idea is to accelerate the commercial activities. Actually, based upon funds. Actually, who is going to be the first winner in sending videos from the lunar surface to the planet, and the winner will be given 20 million yen or 2 billion yen in Japanese yen. So this competition race is going on, and Google has been a sponsor. So it's called the Google Lunar X Prize. And recently, they picked up the best teams, and actually in the Google Lunar X Prize, the milestone prizes, the winners been announced. Actually, in January this year, actually 5 teams been announced. Actually, I represent a team called Hakto, and actually I'm so happy to be a part of these 5 teams. So in other words, we are one of the top 5 players. And if I may, you are the only Japanese participant, right? That's right. And globally, 18 teams. Actually, in Japan, the recent Japan, we are the only the organization. So I happen to have a rover, and which played a very important role in enabling us to get this milestone prizes. Well, the probably communication has been cut off. Sorry about that. Please look at the right-hand side. It's right. They're supposed to come out of the curtain, and due to the lack of communication, sorry about that. We have developed a mini school rover, and actually, other teams actually have tens of the kilometers and tens of hundreds of kilometers, the kilos in weight, and this is really this weighs only 8 kilos. So it is quite minuscule in terms of weight. Actually, lunar surface and consists of lots of sounds. It could be quite slippery. So mobility of a device like this is going to be quite important in our development. As for the components, by the way, well, the space development usually special devices, electronics devices, are going to be used. But we are different. We like to fully utilize costs and products and reducing our cost. Sorry about this demonstration using rover. Well, allow me to move on. So we have this robot developed. Actually, and, this is a joint development together with Tohoku University. And there are certain features, in a place like this, with human beings and simply cannot enter. And so, still access to these places will be quite important. For example, fire, and also the space. I think is one of those places, and also the water and desert and nuclear facilities. And so, within those, with the robots, we should be able to have access to these quite dangerous places. And this is one of the important ideas behind our development. Tohoku University actually has excellent examples. If I'm now like to introduce some of them, now this is a robot called Quince. This Quince robot has been utilized since the accident of the tsunami, after tsunami, Fukushima nuclear accidents. This is a very Japan's and first trial, actually, joint development and development of this Quince robot. And besides that Quince, the robot that you have seen so far running on the planet, and this is combination with the robot and a drone. So actually, the mapping can be done. The mapping the whole structures of the buildings, facilities. And furthermore, external the application, outdoor. This the UAV and drone is the major player here. And actually, they are flying over the volcanic the places. So we human beings simply cannot have access to these dangerous places. But again, the drone and robots, that combination is going to help us. And this is a set of series of examples by the Tohoku University, and we would like to fully utilize these technologies so that, as you see in our tagline, expand our planet, expand our future. And I would like to make a contribution so that the people want in the future and can start living. Thank you again for your presentation, and I was paying attention to your presentation as well as into the rover. You talked about space and living in the space, and also the robots will enable us to have access to those dangerous places. And one of the themes in this session is how robots are going to change the society. This is a question I'd like to ask Hakamada-san first and to respond.
That's exactly what we're trying to achieve and explore now. To expand our human capabilities is I think that the robots can do and help us, and thus changing our lives. The very simple example is exploring the volcanoes. You can find out what's happening around the volcano, and so that we can improve the safety of human. And also in space, robots can really help us create a foundation for our lives, possibly in the space in the future. So, Mr. Hakamada, you've been working in the space area, and Charlie-san, you're focused more in the industrial area. How do you think robots will change the society?
Yes, well, robots are another productivity tool and a significant impact productivity tool. So, in my mind, there are many, many positive aspects. When you introduce robots as a productivity tool, and the cost to make the product go down, the price to pay for the product goes down, the standard of living rises. And so it's a very positive impact on the standard of living. I would also say that robots are now allowing manufacturing plants to remain onshore or even reshore. And it's been proven many times that for every manufacturing job, and there's no such thing, by the way, as lights out factory. Every factory that uses robots has many other jobs. And there's a multiplication factor for every manufacturing job, additional jobs in the supply chain. So I think from a domestic policy, whether it's Japan, United States, or Germany, implementation of robots raise the standard of living in factories, implementation in factories, raise the standard of living, but also create more factories and more jobs.
チャーリーさん、その今、労働の生産
You said that the productivity will be enhanced with the introduction of robots. But while the life becomes very convenient, but I'm sure you were asked many times, would the robots be taking away the jobs from us? Do you think that the robots and people can live together, coexist?
Yes, I think that history has shown that, as I said earlier, robots create jobs. There's an association in the Silicon Valley called Silicon Valley Robotics, that did a study from 2009 to 2013 and interviewed companies who used robots. And they showed that there was actually an increase in the automotive industry alone of using robots of 150,000 jobs, and overall 1 million new jobs from companies using robots. That's the good news. It is clear, though, that that employees' jobs do get replaced. Most of the time, these jobs are very mundane, many times unsafe. And as we've seen in China, in some of the contract manufacturing factories, even psychological health problems. But nonetheless, these jobs do get replaced, and there is an issue of displaced workers from a micro perspective, but from a macroeconomic perspective, I say it's very healthy.
わかりました。ありがとうございます。
Thank you very much. Seems like a robot moved momentarily. Mr. Hakamada, I'd like to ask you the same question. Can robots and human beings coexist? Ultimately, I think they will coexist. At the introduction, however, there may be some hurdle. Especially in Japan, robots, there is some illusion about robots. Are you talking about Doraemon? And also Atom, kind of a multi or omnipotent robots, multi-capability robots, humanoids. But robots are created by human beings, so it can basically function based on the hypothesis of human beings come up with. And by combining different functions, however, though, you can make the robots better, but it does cost a lot to do so. So because of that, and also another challenge is that the safety and quality are initial hurdles. And so for omnipotent, omnifunctional robots, there are risks involved, even in application for the nuclear power plant. That's the case in Japan. Especially in Japan, I think people tend to think of the undersized rovers are now finally moving. So there are factors of human side while they can automate the operation. Yes, true. Like a Google car have automatic driving, and when human beings get on the car, if the accident takes place by robots operating the car, so that's the hesitation at the moment. But the recent development is that the robots are used to assist the human capabilities and thus assist. So is the word assist is the key word? Yes. Ultimately, people have to make the decisions and judgments. Charlie-san, we've been talking about the situation in Japan. In Japan, especially to robots, safety is always a big concern. How about the situation in the U.S., in Germany? Is there similar concern for robots?
Yes, there's concern about safety. In Europe, there's something called CE certification. CE certification means that a product is safe. As an example, this Grabit gripper is CE certified. Even though it's high voltage, I turn it on, it doesn't shock me. There's regulations about the safety of robots. I think one of the areas that's very interesting, and we heard about it in the prior session, about artificial intelligence, software, creating software. And the question then becomes, can robots be safe with artificial intelligence? And I think it's a very important question. And we have to, I like 3 old laws. Hold up your hand if you've heard of Isaac Asimov. He's a Czech playwright who wrote a series of plays called I, Robot. And this was 1942, but he was very forward-thinking. He had 3 rules of robotics. First rule is a robot can never hurt a human. Second rule is a robot always obeys a human except when in violation of the first rule. And the third rule is a robot will always ensure its ongoing existence except when in violation of Rule 2 and Rule 1. And I think this was before the digital age, these rules are in place, and I think that we have to follow these rules as we look at artificial intelligence with robots.
なお3つのルールがあると人間に脅威を与えることはない。すごい初めて。
Oh, with 3 rules. I did not know about those 3 rules, not to hurt human beings and others. For Japan, since the 1980s, in the area of industrial robots in Toyota and automotive industry has driven the interaction and have very high market share. But in the most recent robot industry, based on the media reporting, and Google is working with the University of Tokyo ventures and researchers, young researchers. So many people are concerned about the Japanese robotics industry for the future. You know the scene and know what Google is doing. Hakamada-san. The first thing I can say is that in Japan, robots are a very active area of research in Japan. But what we need to be careful in the future is Japan is very strong in hardware side and manufacturing. And our robot does benefit from the Japanese manufacturing capability and to come up with this kind of robot. However, on the other hand, robots, especially in the application in the space, you cannot solve issues, challenges just by hardware. You do need to use software. And so robot by itself cannot achieve a huge function or multiple functions. And in fact, you have to have software driving the managing the robots. And the hardware is only the one of the technical component managed to provide a overall service of significance. So there is hardware and software. Yes, we are developing a compact robot. Now, this one single unit can do so much, can only do so much. In the future, one can make it larger. And that's only hardware side solution. And we think it's more promising to have multiple compact robots and have them collaborate over the network. So that requires a software component as well.
Same question goes to Charlie-san. Well, actually, we have lots of activities in industrial robots, but in Japan. But actually, in Google and the Silicon Valley and companies actually have become a lot more dominant, and they are actually recruiting, acquiring the businesses. And any thoughts in this regard, please?
Well, certainly Google and Amazon are very active in robotics, buying companies. Amazon's interests are a little more clear than Google. I think we're still speculating with all of Google's plans. But let's back away for a minute. Japan leads the world in installed robots per capita, in robot density. Nobody has more experience in how to make robots work. And so I'm from the Silicon Valley, and we're quite proud of our innovation. But there is a little detail that goes after the innovation. The product has to work. And I think we have to keep that in mind, and I actually think that it's an advantage that the Japanese robot community has, the extensive experience on how to apply robots, how to make them reliable, how to ensure payback for the value to the customer is unique, and I think Japan has a big advantage over the rest of the world in that regard.
ありがとうございます。
Thank you for that response. And another question, finally, it goes to you. Singularity, this word, AI, and is to advance. Of course, and that is going to give us a lot more conveniences. But again, someday in the future, with an AI backed up and robots and may control human beings. You talked about the 3 rules, but you may tell us, and we shouldn't be right about it. But any thoughts in this regard, please?
And your question is robots, new robot applications in the future?
With AI robot. Yeah.
Yeah, I think the interesting thing is AI is being enabled by sensing, and machine vision, as an example, is going to enable so much use of artificial intelligence. I used to market machine vision for robots for $15,000 per robot, and we sold a lot. Today, you can get a high-resolution camera, the camera that goes into the cell phone, for $25. And so machine vision, and with all the software development, is in fact making, I think, enabling artificial intelligence and other sensing, haptic sensing, and so forth. So I believe that the future is incredible for robots. But I also, we heard the point earlier, everybody thinks of the humanoid robot. I think the robot technology doesn't have to be a humanoid walking robot. The technology, the sensing, the low-cost actuation, maybe 2-axis, 3-axis devices, can be unloading in the kitchen, unloading dishwashers, in the fast food restaurants, flipping burgers and assembling sandwiches. I think that there's just going to be a proliferation of robot technology, not just humanoid technology, but robot technology in general in the manufacturing and in the services industry.
ありがとうございます。袴田さん。
Hakamada-san, same question, please. Going beyond the singularity point, whether or not AI-backed robot is going to control us, human beings. Well, going beyond the singularity point, I think we're moving into the area the human beings are not going to be able to control robots. I think that's the kind of implication I got out of your question. Yes, that could be one possible story, particularly the AI, artificial intelligence. Well, it's been limited within the programming scope based upon the assumption we people have written, and it is in that process intelligence has been built. But now, what's going to happen if it goes beyond human beings and assumption? So robots may advance going beyond these traditional lines. So if that's the case, again, we may go beyond the singularity point. So you see that possible? Well, we have to, again, be reminded of the 3 rules explained by Charlie. Yes, nuclear application is just one possible story. Here, I'd like to get your attention again. Thinking on robots ultimately are going to help us in those areas. Asthma, for example. And again, Asimov's robots 3 roles, and actually have been already introduced, several decades ago. So thinking on that rules and as well as advancement of robots, I think we need to keep an eye on both aspects. If time allows, and I wanted to ask a lot more questions, but time will not allow me to do so. So maybe it's time for me to receive questions from the audience. Please show your hands. 2 people in the front side, please. Thank you. Japan leads the world when it comes to robots. But robot ventures, whether or not you've seen any possibilities of robots and entrepreneurs who be listed on the stock exchange, and whether or not venture capitalists are willing to make investment into those entrepreneurs. And the second person, please. Thank you. Japan excels in hardware, and I say that. And also, you told us that both hardware and software will be needed. So, in order for us to be competitive in hardware and software, what are the important things in terms of education, in terms of the behavior on the side of the enterprise? Well, the second question first. And Charlie, any response to the hardware and software and education? Any response from your side, please? Hardware and software education, please.
Yes, I think that in the robot industry, the most impressive software people I ever met in the robot industry were actually mechanical engineers who were good programmers. And I think that my only advice is if you want to succeed in the robot industry, don't be just a software person. Don't be just a mechanical engineer. Don't be just an electrical engineer. The beauty of the robot is that it's a multidiscipline technology. That's why I love robotics. It's software, it's hardware, it's direct drives, it's harmonic drives, it's networking. And now the robots are becoming part of the Internet of Things. And so I guess my response to that question is the best education is a multidiscipline education.
その点で私からもよろしいですか。航空宇宙っていうのも
Well, in space and aerospace engineering actually is becoming the multidisciplinary nowadays. And furthermore, actually, I actually went graduated from the graduate school in the USA, and that experience actually realized me that, and actually, Japanese laboratories actually seem to be way ahead too. So that is also critical. Actually, system integration also is going to be quite critical. And when it comes to this aspect, not many activities are underway, if I'm not wrong. In the U.S., conceptual design is one of the domains I think I can talk about. The design and also decision-making orientation, and also the aerospace actually covers all these important things. And I was quite impressed with that multidisciplinary activities among the so many Americans. I think we need to have those people.
Mr. Hakamada, you've been engaged in the Google project, and do you think that the robot industry can get the financing so that it become even the going public in the future? Yes, the robots startup and ventures are not really at the stage of going public, even in Silicon Valley. And while they're getting a lot of attention at the moment, but I think it's still in the process of developing. And now, will they be qualified for the going public in the future? I don't think that's not the case. I think that is in a technology area which society will require for sure. And companies working in that area should be allowed to go public and become a part of the social infrastructure so that they can make better, solid contribution to our lives. In terms of getting finances, investment, and that is not that difficult in Japan. Getting investment, well, it's still very challenging, frankly. Till up until recently, even in the general IT area, it was difficult to get the funding, and robots and its application in space. I think we need magnitude or more bigger scale of investment. And whether Japan can come up with the risk money financing compared with abroad, especially compared with the Silicon Valley situation, it's not that abundant. Especially whether there are people who can assess technology, and in the U.S., people who have been working in the technology area are now involved in the investment. And maybe you can ask one or two more persons. Please use microphone.
First question is, what are the major application or market for you two companies? And the second question is, what are the major technological or business challenge you are currently facing? Two questions. Thank you.
Thank you. チャーリーさんお願いしてよろしいですか。
Charlie さん、please. 先ほど話をしましたベンチャーキャピタルの話がありました。
Robot company on Sand Hill in Silicon Valley competing with social media, and that wasn't easy. But there are some companies now who realize the value of robotics if you have big applications that represent big markets. We've identified two at Grabit. One is, frankly, very near term. There's very active reshoring in Europe and the U.S. for sewing automation, for sewing plants, to rejoin fabrication of material plants. In China, there's a very strong move to automate sewing plants so they don't lose the plants to Vietnam. Meanwhile, Vietnam labor rates are going up 40% a year. So this application will be Vietnam as well. So we see electroadhesion as being uniquely capable of handling very flimsy, hard-to-handle materials. And then the second large vertical that we found that's second on our priority, and I showed in the PowerPoint, is order fulfillment, each pick, the handling of individual SKUs in the Amazon, Targets, and Kohl's, et cetera, retail order fulfillment centers.
ありがとうございます。じゃあ畠田さんも同じ質問2つ。
はい、
Same question to Mr. Hakamada. In terms of the market, as I discussed earlier, that the space development has moved from the government endeavors to private sector endeavor. And so the exploration is also conducted. And so the private only, not just the collaboration of the government and the private, but in the U.S., there is a legal framework being developed to allow lower the private sector. And even the U.S., they talk about the ownership of smaller planet as well, asteroid as well. And so in the space, however, it is not easy to carry out experiments casually. And so whoever does that first will find themselves in a very strong position in the market. Thank you. I hope we had more time for further questions. So finally, before we close, I'd like to ask the two gentlemen to talk about the future of the robots. Comment.
I've been in the robot industry for decades, and I've never seen a better climate for robotics than now. The costs keep coming down. Mechanical arms themselves are becoming commodities. There's even new technologies like electroactive polymer, artificial muscle technology that some people think will replace gears and motors. And I think the going forward, as I said, there's going to be this proliferation in service and manufacturing industries. And we've seen when Google bought Boston Dynamics, Boston Dynamics has shown, I think, the first robots, and Toyota has done some work there too, of going across terrain and being able to climb stairs. So but all this is exciting and fun to watch, but what really drives it is low cost. And the same reason that drones used to cost $1 million for the Department of Defense in the U.S., millions of dollars, and we bought our drone at Grabit for $400. The same thing applies to robotics. Consumer electronics technology, low-cost consumer, high-volume electronics technology is just going to enable robots to grow more rapidly than we've ever seen. And again, I think Japan has a tremendous opportunity here with your base of experience to take advantage of that technology curve.
Thank you.
Well, for us, right now, we are participating in the Google lunar experiments with Hakuto. I think our challenge is very promising, and we hope to leverage that experience to open up our market and business growth. And in terms of the robot industry, there are a number of applications possible for robots. The areas where humanly inaccessible area can have robots accessing area. And that's only one of the application areas. And I think while there are many possible applications, what is the priority and what will come first is difficult to predict. But I think it is clear, though, that the robots will get into our daily lives, domain of daily lives. Not going to be like humanoids coming in, Doraemon, or. But I think before we know, we'll be surrounded by different robots. Finally, Google projects. When Luna X Prize is deadline by end of the 2016, and we just announced recently that we are partnershiping with U.S. landing company. We will be launching the second half of 2016. And Charlie-san and Hakamada-san, thank you very much. And you have shared with us what we can expect. And it's not the robots taking away our jobs. And I was very excited to hear what you had to say. And in Japan, we are concerned about the shortage of workforce. And so robots can really help us in that regard, and also can make us even happier. And so thank you very much for your good work and good presentation today. And thank you very much. With that, I would like to conclude this session. Thank you for your participation as well. Thank you very much, everybody. Now we will be changing the stage, and there will be a few minutes before we can start the next session. Thank you.